What if the universe isn't as orderly or predictable as we think? What if, out there in the vast cosmic ocean, there are celestial bodies that defy our deepest understanding of how planets form, how they behave, and what's truly possible in the cosmos? In this video, we're diving into the astonishing realm of 10 planets that baffle scientists. Worlds that break the rules, challenge established theories, and hint at secrets that could revolutionize our knowledge of the universe. From strange hot Jupiters that shouldn't exist, to diamond planets, and even a potential planet 9 lurking in our own solar system. Get ready to have your cosmic perspective completely and trust me, the #1 planet on this list is so peculiar, it could force us to rewrite the textbooks on planetary evolution. You're about to explore extreme temperatures, impossible composition, and orbital dynamics that leave astronomers scratching their heads. Can you picture a planet so dark it reflects less light than black acrylic paint? Stick around, because I'm going to reveal that true cosmic enigma in the middle of this video. Before we embark on this stellar journey, do me a quick favor, hit that like button, share this with a friend who loves gazing at the stars, and if you haven't already, subscribe and ring that notification bell so you don't miss out on more mind-bending content from 360 World. And I want to hear from you. Which of these cosmic oddities do you find the most intriguing? Drop your thoughts in the comments below. 10 Mercury, the solar system's oddball. Have you ever stopped to think about our solar system's smallest planet? Imagine a tiny, innermost planet with a disproportionately large metallic core, a bizarre magnetic field that shouldn't exist for its size, and ancient lava flows that behaved more like syrup than tar. This isn't just the closest planet to our sun, it's Mercury, and its eccentricities have been baffling scientists for decades, challenging our fundamental assumptions about how rocky planets form and evolve. Why is Mercury such a cosmic troublemaker? Mercury is definitely the odd one out in our solar system. Unlike Earth, where the core makes up about 15% of the planet's volume, Mercury's massive metallic core accounts for a whopping 60%. Scientists debate whether it formed this way naturally from metal-rich building blocks, or if catastrophic collisions early in its history stripped away its outer layers. Perhaps even strangers, it's a magnetic field. For such a small, slowly cooling planet, Mercury shouldn't really have an active magnetic field at all. Yet, unexpectedly, it does. Recent laboratory experiments and thousands of computer simulations are finally starting to unravel Mercury's mysteries. But its unique composition and persistent magnetism continue to challenge existing planetary formation models. As we discover more rocky planets around distant stars, Mercury serves as a crucial test case, close enough to study in detail, yet alien enough to challenge our assumptions about planetary formation, the smallest planet. Yet, one of the biggest mysteries, what do you think is the wildest theory about Mercury's past? Let me know in the comments, and brace yourself, because our next planet is so hot, it's literally evaporating. 91WASP12b, the planet in a death spiral. Imagine a gas giant larger than Jupiter orbiting its stars so incredibly close that its atmosphere is being violently stripped away, creating a death spiral that will eventually lead to its fiery demise. This isn't a distant science fiction scenario. It's WASP12b, an exoplanet that's being consumed by its own star. And its rapid destruction challenges our understanding of extreme planetary interactions. How can a planet exist so close to its star without being instantly torn apart? Discovered in 2008, WASP12b is a hot Jupiter. Located about 870 light-years from Earth, it orbits its star in just over 1 Earth day, making it one of the closest orbiting exoplanets known. This extreme proximity means it's constantly bombarded with radiation, heating its atmosphere to an incredible 4,000 degrees Fahrenheit. Its gravitational interaction with its star is so intense that the planet is being stretched into an egg shape, and its outer atmosphere is visibly being pulled away, forming a comet-like tail of escaping gas. This process suggests that OSP12b has only about 3 million years left before it's completely devoured by its star. Its existence challenges models of tidal forces and atmospheric escape, pushing the boundaries of what we thought was stable in a planetary system. A planet on a countdown to destruction. What do you think it would look like from its surface? Don't go anywhere, because our next world is a real-life diamond planet. 855 Concrete E, the diamond planet. Could there be a world made entirely of diamonds? Imagine a super-Earth so incredibly hot and dense that scientists once hypothesized its entire interior, or at least a significant portion of it, might be made of diamond. This isn't a fantasy from a pirate map. It's 55 Concrete E, a planet whose bizarre composition and extreme conditions defy easy classification, constantly puzzling astronomers. Is it truly a diamond world, or something even more volatile? Located about 41 light years away, 55 Concrete E is roughly twice the radius of Earth and 8 times its mass, making it a super. Its extreme proximity to its star results in surface temperatures soaring to around 4,900 degrees Fahrenheit. Early research, based on its mass and radius, suggested it had a significant carbon content, leading to the exciting diamond planet hypothesis. However, more recent studies, utilizing data from the James Webb Space Telescope, indicate a more complex scenario. While carbon could still be abundant, the intense heat likely means it's covered in oceans of superheated lava with an atmosphere of vaporized rock. The diamond planet theory isn't entirely dismissed, but its true nature as a scorching lava world with exotic chemistry continues to keep scientists intrigued and perplexed by its extreme conditions and potential composition. A world that could be made of diamonds or constantly boiling lava. Talk about extremes. Up next, a planet with a truly bizarre, inexplicable atmosphere. 7NGJ436 be the planet with mysteriously missing methane. Imagine an entire planet's atmosphere defying basic chemistry. A warm Neptune exoplanet, roughly the size of our own Neptune, yet its atmosphere bafflingly lacks a key ingredient that should be abundant: methane. This isn't just a minor atmospheric anomaly. It's GJ436b, a planet whose atmospheric chemistry defies standard planetary models, leaving scientists struggling to explain how this crucial gas is so strangely absent. Where did all the methane go? GJ436b, located about 33 light years away, is a Neptune-sized exoplanet orbiting its star very closely, resulting in an estimated temperature of around 970 degrees Fahrenheit. According to standard atmospheric models for planets of its size and temperature, its atmosphere should contain significant amounts of methane. However, observations from the Hubble Space Telescope revealed a startling absence of methane, replaced by an abundance of carbon monoxide. This missing methane mystery is a significant challenge to exoplanetary atmospheric science. Proposed explanations include a unique chemical process occurring in its hot atmosphere that prevents methane formation, or perhaps internal dynamics that are somehow suppressing its presence. The puzzle of GJ436b's atmosphere is a crucial case study for understanding the diverse and often unexpected chemistry of a planet whose very air defies our understanding. What other atmospheric secrets are out there? Don't go anywhere, because our next planet is one of the darkest ever discovered. 6 TRES-B, the planet darker than coal. Can you picture a planet blacker than anything you can imagine? An exoplanet, similar in size to Jupiter, that is so incredibly dark that it reflects less than 1% of the sunlight hitting it, making it blacker than black acrylic paint. This isn't a shadow, it's TRES-B, the darkest known exoplanet, orbiting a star just 750 light years away. Its extreme darkness remains a profound mystery to astronomers. Why is this planet so incredibly dark? Discovered in 2006, TRES-B is a gas giant that orbits its star so closely that its surface temperature reaches over 1,800 degrees Fahrenheit. Despite these scorching temperatures, which should make it glow red hot, it is astonishingly dark. For comparison, Jupiter reflects more than a third of the sunlight that reaches it. Scientists theorize that TRES-b's atmosphere may contain light-absorbing chemicals or clouds made of vaporized elements like titanium oxide, which can absorb light instead of reflecting it. However, the exact composition and mechanisms that make it so uniquely dark are still being investigated. This coal-black planet continues to be an enigma, challenging our understanding of atmospheric composition and reflectivity in extreme exoplanetary environments. A cosmic void, absorbing almost all light. What do you think it would feel like to be on such a dark world? Coming up next, a giant planet orbiting a tiny star, a cosmic pairing that shouldn't exist. 5. TOI 6894b, the giant planet around a tiny star. Imagine a giant planet forming where we thought it was impossible. A gas giant, about half the mass of Saturn, orbiting a red dwarf star that is only 20% the mass of our sun. One of the smallest stars known to host such a large companion. This isn't just an unusual pairing. TOI 6894b challenges long-standing theories about how giant planets form, especially around small stars. How did such a large planet come to exist around such a tiny star? Discovered recently, TOI 6894b is a groundbreaking find because current planet formation models suggest that giant planets are rare around low-mass stars, like TOI 6894. According to the most common theory, a massive solid core must form first, to then accumulate a vast envelope of gas. Tiny stars are thought to have smaller protoplanetary disks, providing less material for such a massive core and gas envelope to form. The existence of TOI 6894b throws a wrench into these models, indicating that our understanding of giant planet formation is incomplete. Scientists are now exploring alternative theories, such as gravitational instability within the protoplanetary disk, or even a different type of core accretion that can occur in less dense environments. This impossible planet is a cornerstone for rethinking how common giant planets might be in our galaxy, a cosmic pairing that defies the rules. What other cosmic duos could be out there breaking all our theories? Don't go anywhere, because our next planet is like something out of a science fiction movie with strange, fast winds. For Koro to be the planet with backward winds, can you envision winds blowing in the wrong direction on a scorching alien world? A hot Jupiter exoplanet tidally locked to its star, meaning one side perpetually faces its scorching sun. You'd expect the hottest point to be directly under the star and the winds to blow eastward, but on Koro 2b, the hottest point is inexplicably shifted westward, and the winds appear to blow in the opposite direction. This isn't just an atmospheric anomaly, it's a profound puzzle challenging our models of atmospheric circulation on Why are the winds blowing backward? Koro b is a massive gas giant, 1.4 times the radius of Jupiter, orbiting its star in less than 2 Earth days. It's tidally locked, so one side is always facing its sun, leading to extreme temperatures. Standard atmospheric circulation models predict that the strong winds on such a tidally locked planet should blow eastward, creating a hot spot that is slightly shifted east of the substellar point due to advection. However, observations from the Spitzer Space Telescope revealed that Koro 2b's hotspot is inexplicably shifted westward. This backward winds phenomenon challenges current understanding of atmospheric dynamics on hot Jupiter. Theories include strong interactions between the planet's atmosphere and its magnetic field, or incredibly slow planetary rotation, but none fully explain this bizarre atmospheric behavior, making Koro 2b a unique laboratory for extreme atmospheric physics. Winds blowing the wrong way on a scorching alien world. What other atmospheric phenomena are waiting to be discovered? Now, prepare for the top 3, which delve into some of the most profound planetary mysteries. The next one is about a planet with a truly chaotic orbit. 3. HR 5183b, the eccentric giant. Imagine a planet's orbit that's more like a wild slingshot than a smooth circle. A planet 3 times more massive than Jupiter, orbiting its star in an incredibly highly elliptical path that takes 74 years to complete. Nearly as long as Uranus's orbit in our solar system, but far more chaotic. This isn't a stable, circular orbit. It's HR 5183b, an eccentric giant whose bizarre, stretched out path challenges our understanding of how planets form and how stable planetary systems are. How did this giant planet end up in such a wild orbit? Discovered in 2019, HR 5183b is a gas giant with one of the most eccentric orbits ever observed for Instead of a relatively circular path, it takes a long, looping journey around its star, spending most of its time far away, then making a swift slingshot-like pass close to the star. This highly unusual orbit is difficult to explain by standard planetary formation theories, which generally predict planets forming in more circular paths. Scientists speculate that HR 5183b might have been gravitationally kicked into this eccentric orbit by an interaction with another massive, now missing planet in its system, or perhaps by a close encounter with a passing star in its early history. Its existence forces astronomers to consider more violent and dynamic scenarios in the evolution of planetary systems than previously assumed, making it a critical case study for understanding planetary migration and stability. A planetary slingshot. What does its existence tell us about the hidden chaos of forming solar systems? Up next, a planet that's mysteriously missing a core. 2. Kepler-16b, the real-life Tatooine, but more mysterious. Can you believe a real-life Tatooine exists? And it's even stranger than fiction? You know, Tatooine from Star Wars, a planet orbiting 2 suns. But what if there's a real-life circumbinary planet, Kepler-16b, that not only orbits 2 stars, but has properties so strange that its very existence challenges fundamental theories of planetary formation? This isn't just a sci-fi dream come true. Its baffling characteristics are forcing scientists to rethink how planets come into being around binary star systems. Discovered in 2011, Kepler-16b was the first definitive circumbinary planet found, meaning it orbits 2 stars. It's a Saturn-sized gas giant located about 200 light-years away. What makes it mysterious is its size and composition relative to its twin suns. Planetary formation models suggest that it should be difficult for planets, especially gas giants, to form in the unstable gravitational environment of a binary star system. Furthermore, its current location is puzzling. It seems to be too close to its stars to have formed there by the standard core accretion model. This implies it might have formed much further out and then migrated inward, or that planetary formation around binary stars is far more common and varied than previously thought. Kepler-16b is a living laboratory for testing the extremes of planetary birth and evolution, constantly pushing the boundaries of what astronomers believe is possible in the universe. A real-life Tatooine with its own set of cosmic questions. How many other Tucson worlds are out there challenging our theories? And now, for the #1 planet that truly makes scientists lose sleep, this is the one that could change everything. 1. Planet 9, the hypothetical gravitational ghost. Could our solar system have a giant, unseen sibling lurking in the dark? What if deep in the icy, unexplored fringes of our own solar system, there's a massive, unseen planet, possibly a super-Earth or mini-Neptune, whose gravitational pull is subtly shaping the orbits of distant icy objects, but which we haven't actually seen yet? This isn't a sci-fi fantasy. It's Planet 9, a hypothetical but strongly suspected 9th planet whose potential existence challenges everything we thought we knew about the architecture of our own cosmic backyard. Is there a giant ghost planet lurking just beyond Neptune, waiting to be found? The existence of Planet 9 was first proposed in 2016 by Konstantin Batygin and Michael Brown, based on the peculiar, clustered orbits of a group of extreme trans-Neptunian objects in the outer solar system. These objects move in highly elliptical paths that seem to be shepherded by the gravitational influence of a larger, unseen body. Statistical analysis suggests that the clustering is highly unlikely to be random, pointing strongly to the presence of a massive, distant planet. Estimates suggest Planet 9 could be 5 to 10 times the mass of Earth, orbiting the Sun hundreds of times farther than Neptune, with an orbital period that could be thousands of years. Despite extensive ongoing searches, Planet 9 remains elusive, a theoretical gravitational ghost whose potential discovery would revolutionize our understanding of solar system formation and evolution. Its existence would fundamentally alter our cosmic address and rewrite the history of our own planetary neighborhood. A giant planet hiding in our own backyard, if found, it would be the discovery of the century for planetary science. If these mind-boggling planets left you craving more cosmic mysteries, then you absolutely have to check out our next video right here, where we explore even more bizarre astronomical phenomena that defy current scientific understanding. You won't want to miss it. And remember, if you only scrolled to the end of this video, you missed out on the weirdness of Mercury's magnetic field and the perplexing chemistry of GJ436b. Definitely go back and watch those parts. Before you go, hit that like button one last time, share this video with anyone who loves to gaze at the stars, and if you haven't subscribed yet, what are you waiting for? Join the 360 World community and let's keep exploring the universe's most astounding secrets together. Until next time, stay curious, stay questioning, and keep looking up.